Hello. So oftentimes this year we've been working with the laws of exponents, but I bet you never knew that Coach Fred had a favorite. Coach Fred has a favorite law of exponents, okay? And this law can only be used if it's an equation. So I think that's probably why it's my favorite, because it's a really quick and easy way to solve an equation. And it can only be used to solve an equation, okay? It can only be used if the bases can be written the same. It can only be used if bases can be written the same. And I'm going to show you what I mean by that, okay? But it cannot be used in an expression, and that is really, really important. So I asked you to try and do some mental math, and those examples that you found, some were hard and you might not have been able to find them, you can use Coach Fred's favorite law of exponents to solve them, okay? So Coach Fred's favorite law basically says, if we look at something like this, 2 to the x equals 2 to the 5. As long as these numbers are exactly the same, the bases are the same, and there's no other things being multiplied, meaning there's a single monomial equaling a single monomial. If the bases are the same, then you can cancel them, so x equals 5. This is a pretty clear example. 2 to the 5 would have to equal 2 to the 5. Again, it has to be single monomials, so you can't have other things being multiplied to it or added to it, and the bases have to be the same. All right, so let's look at some harder examples. 2 to the x equals 32. To solve an exponential equation, when the bases can be changed, you look at the number and see if you can write 32 and 2 with the same base. All right, so I look at 32 and I remember that 2 to the 5 is a way to write 32. So I can rewrite 32 as 2 to the 5 power. Since the bases are the same, I can cancel the 2's, so x would be 5. Okay? All right, let's look at number 4, a little bit harder. I need these numbers to be exactly the same. 1/2 and 2 are not the same. So you can use the laws of negative exponents and kind of think backwards. I'm going to bring the 2 up and raise it to the negative 1 power. I can rewrite 1/2 as 2 to the negative 1. Remember, 2 to the negative 1 means 1/2. So now the bases are the same, so I can cancel the 2's. So x would be equal to negative 1. It's a really nice process to go through, but it does take some work. All right, let's look at this next one, a little bit harder. 3 to the x equals 1/9. Well, I know that 3 and 9 can be written as the same base because 9 is just 3 squared, but it's in the bottom of the fraction, and that's going to give me 1 all over 3 squared. So I actually am going to do this. I'm going to make it 3 to the negative 2 power. 3 to the negative 2 is 1/9. All right, in this case, the bases are now the same, so they cancel. So x equals negative 2. Harder. Now in this one, it's different. I want you to look for a second and see what you see that's different about this one than the other examples. Hopefully that you notice that there's this 2 here and there's this 2 here. There's 2 different things being multiplied. It needs to be a single number before. So you have to do some work. So the first thing that I'm going to do is use my law of exponents on the right side, remembering that this is 2 to the 1 power, and then use power times a power, add them high, so 2 to the 1 plus 1/2, which gives me 2 to the x times 2 to the 3 halves, because 1 is 2 over 2. Now the bases are the same. I have a single monomial. The 2's now cancel, so x equals 3 halves. I really want you to spend time looking at that. If you've written the notes, it might be worth your time to rewind and watch it again. This is very different, and you cannot just say that x equals 1 and 1/2, okay? Like you have to add them together first. That one works out to work like that. All right, so let's look at number 8, okay? Because I think I gave you the exact same one twice. So number 8, 4 to the x equals 4 to the 2 times 4 to the 1/2. Okay, I've got to combine these before I can use Coach Fred's favorite law. So 4 to the x equals 4 to the 2 plus 1/2, power times the power, add them high. So that gives me 4 to the x equals, so it's 4 halves plus 1/2, which is 5 halves. So 4 to the 5 halves. Remember, these bases have to be the same, and so they are now, so x equals 5 over 2. All right, let's try a couple harder ones. 4 and 32. Now, 4 is a factor of 32, but I can't write 32 as a base 4 number because 4 to the 1 is 4, 4 to the 2 is 16, and 4 to the 3 is 64. Sometimes you do have to change both sides to make them the same. And so I recognize that 4 I can write as a base 2 number, so 2 to the 2, to the x power. I rewrite it. And 32 can also be written as base 2, so 2 to the 5 power. Now I use the law, the power 2 times 2 a power, multiply, so this becomes 2 to the 2x equals 2 to the 5. All right, now the bases are the same, I cancel, so 2x equals 5 and x equals 5 halves. All right, let's test that. So 4 to the 5 halves. 4 to the 5 halves is the square root of 4 to the 5th power. Square root of 4 is 2. 2 to the 5 is 32. Wow. Mind blown. Wow. All right, let's try this one. 9 to the x equals 3. Okay, so now this is where I'm working with just the left side. I know that 9 can be written as a base 3 number. So 3 squared to the x equals 3 to the 1, making sure we remember that it's 3 to the 1. Power to a power, multiply, so 3 to the 2x equals 3 to the 1. Bases are the same, cancel them. So 2x equals 1 and x equals 1/2. Okay? All right. So hopefully Coach Fred's favorite law doesn't look too hard. It can get trickier, but remember, you have to always remember you're trying to make the bases the same. Sometimes you only work with one side. Sometimes you have to work with both sides. And you really just need to think about all those number relationships that we've been working on a lot this year. All right, guys, have a great night.